Okay, so the next one, box plot. So this one you can use with a very large set of data as long as you know 5 things. The smallest value, or the minimum value, the largest value, or the maximum value, the median, and then 2 other things called the hinges. Once you know all this, what you're going to do is you're going to draw something that looks like this to scale. So this would be, instead of the word minimum here, would actually be the value of the smallest number. This would be the value of the largest number. So this could be like, say, 2, and this could be like 20 or something. The median, you know how to calculate. We did that in the first section, section 1.1. So calculate the median and put the value of the median there. Now the hinges. The hinges, this is the lower hinge. It is the median between the minimum number and the median. The upper hinge is the median between the median and the maximum number. Now here's the kicker. This semester, you're going to learn a few things in this class, that there are multiple ways of doing it, and depending on who you learn stats from, you're going to learn a different way. However, all of them will give you the same answer. So, for example, there's something we're going to do in the middle of the semester for figuring out probabilities, and we're going to use this table. There are 2 tables out there in the world, the general world, that you can use to answer these questions. If you use one table, you got to do it one way. If you use a different table, you got to do it a different way, but you get the same answer. And it's about 50-50. So chances are, if you took this class from a different professor here, they might use the other table. When I took this class, it was when I was in undergrad and took a bunch of stats classes, literally I think the professors as a joke switched back and forth every other class. There is a case, which is the box plot, where there are 2 generally accepted methods for doing a box plot, and they will not necessarily give you the same answer. So, if you've already learned how to do a box plot, do it my way until you're done with my class, because you might not get the same answer. All right? Okay. And I'll explain where all that comes in a second. Okay, so instead of doing the example in here, we're going to do the same thing as last time. I'm going to put some numbers on the board, and we're going to do this, make an easier one at first. All right, so let's say we have these numbers. 1, 2, 3, 4, 5, 6, and 7. All right, so these are our numbers, and we need a box plot for this. So this is how I do it. I usually put the minimum down, the maximum down, and then scale everything else in between. Now, the reason for that is this. Imagine this is my sheet of paper. I gave the last semester that I taught, that I gave take-home exams, I had a student of mine, and she started doing a box plot. So she put her minimum value line, she drew this over to her lower hinge, then to her median, then to her upper hinge, and now she's at the side of the piece of paper. So what is one to do? Well, erase it and redo it, right? No. What she did is she took a piece of paper that was 8.5 by 11 that she cut into a strip that was about 2 inches wide, 11 inches long, and she taped it on the piece of paper. And then continued this, then folded it up into the paper and handed it in that way. It's like a pop-up book for an exam. It's very exciting for me to grade. You don't have this luxury on your exam. If you have to do one of these, don't do that. Cross it out, do whatever it takes, and do another one. But the way I do it, so I don't have that problem, is I put my minimum value down, and then I just figure out where my maximum is going to be. 1, 2, 3, 4, 5, 6, 7. So I do the scale from the minimum to the maximum first. All right, minimum value, maximum value. What's my median? Remember how hard this is? My median's 4. I can't even draw it right down the center. Unbelievable. All right, so my median is 4. All right, my lower hinge goes, so this is my median. My lower hinge is the median between 1, the lowest number, and 4. So I have 2 numbers left. 2 plus 3 divided by 2 is 2.5. So 2.5. So this is my lower hinge. And my upper hinge goes from the median to the maximum number, which is 5.5. Okay. So this is our box plot. Pretty straightforward. This is an indication, if I'm drawing this, of where the curve goes from going up to angling the other direction. So kind of what our data looks like. All right. If this was our data and you learn this from someone that does it the other way, you're going to get the same answer. However, if we simply eliminate this and do the box plot again, we will get a different answer than the other people will get. Now, for half the time I've taught here at Fisher, I used to do it the other way. The problem with the other way is you have to ask a question and there's 2 ways to do the answer. Too many people are getting confused about that. That's why I switched to this way. We do it one way. It doesn't matter what the data looks like. So I'm going to do it to this data. I'm going to do exactly what I did before. So my minimum number this time is a 1. And my maximum number is a 6. My median in this case is a halfway between here and here, is a 3.5. 1, 2, 3.5. All right? So that is so far the same, right? So we put our median there. Now what do? The lower hinge is between our lowest value and the median. Now that median is not a number in our list, but we still use it because our lower hinge is from the lowest number to the median. So if I do this, my lower hinge is still 2.5. And then if I do this, my upper hinge is still 4.5. All right, that's how you do it for this class. If you took someone else's class that did it the other way, they don't, other than putting this median here, they don't use that. They simply find the median between the lower half of the numbers. And they would have a 2 here and a 5 here. Do not do it that way in this class. Do it the way I showed you. So use the median even if it's imaginary. All right. So now let's do one that's a little more challenging. Okay, so now we have the measurements from the front foot length. The minimum value is 2.2. The maximum value is 2.4. So I put 2.2 as my minimum, 2.4 is my maximum. My median, I just take my fingers and I do this, and I end up with 2 numbers. I end up with 2.3 and 2.35. No, 2.30 and 2.35. Yep, that's right. So I end up with these 2 numbers here. So I have to add them together and divide by 2. So my median is 2.325. And I put that where the median is. Now, I'm going to do the lower hinge. So I take all the numbers up to including the median, even though this median is not actually a number in this data. And then I find the median of that. I'm left with these 2 numbers. I add them together, divide by 2. This is my lower hinge. For my upper hinge, I go from the median to the maximum number. And I find the median of that. It's these two added together divided by 2, which is this. So this is my box plot for those front foot tracks. So you can see from this, think about it. Look how long this tail is compared to this tail. All right? So this is negatively skewed.